Okay. There are no factors of 6 that subtract to give us 2. We cannot factor this trinomial. So we need to make sure that that's not a perfect square trinomial, which it's not. Then we need to make sure the x squared term is has a 1 coefficient, which it does. Okay? And we've got to set this up to complete the square, which means that we are going to isolate, come back here, this by bringing 6 over to the other side, and then we're going to put our parentheses to get ourselves set up to complete the square. So we're going to have x squared plus 2x plus something squared. When I bring 6 over, it becomes positive 6. And when I add something to one side, I have to add to the other, right? Okay. Clint, what goes in the parentheses?
1.
How'd you get 1?
It's half of 2.
It's half of 2. Okay. 1 goes in parentheses, which means that this trinomial factors to give you what, Luke? Square root of this, and this number, and this sign. X plus 1 squared. Okay, over here I've got to actually work that out. That's 6 plus 1 squared, and 1 squared is not 2. 6 plus 1 is 7. Alright, and now I'm set up and ready to go to solve this equation. Hurley, what do I do? Find the square root of both sides, which means on this side I have x plus 1. When I take the square root of both sides, what do I automatically put on the other side of the equal sign? Plus or minus. Can you find the square root of 7? No. And then we finish it by isolating x, which requires us to subtract 1 from both sides. So x was equal to negative 1 plus or minus the square root of 7.
What's the number 32? How do you get the sign?
Number 32?
How do you get it?
When you see a trinomial, and these are easy to factor because there's no number here in front of x squared, we ask ourselves, are there factors of 15 that add up to 8, 3, and 5, right? So this is just factorable. And if they're both minus, that gives me a positive 15 when I multiply it and a negative 8 when I add. And so all I have to do here is set each one equal to 0 and solve for x. And that's much easier than completing the square, because I don't have to complete the square. I can factor. Remember, completing the square is when you can't factor. Okay? All right, so that was number 32. This was number 34. Number 36 was not this. I'm not sure which one this was. This is number 39. Okay, let's do number 36. It's 38. All right. 36 is x squared minus 4x. Okay. Is that factorable? Be careful. You need factors of 5 that add up to 4. Add, because when you multiply, you're getting a positive, so the signs are alike. Factors of 5 do not add up to 4. They subtract, but that's not what I'm looking for here. Okay? So since this cannot be factored, I'm going to go ahead and set it up to complete the square. When I bring negative 5 to the other side, it becomes negative. And now I just need to figure out what goes into those parentheses. 2. Okay? What does this, Luke, factor to give me? x minus 2. Very good. Squared. Equals, and on the other side I have negative 5 plus 4, which is negative 1. Okay? What's the next step, Blake? Take the square root of both sides. Tell me what's right.
X minus 2 equals plus minus I.
Plus or minus I. Very good. Okay? Plus or minus I. Automatically plus or minus the square root of the negative, I classify it as an imaginary number, and the square root of 1 is 1. Yes?
You wrote it as I square root of 1 plus or minus.
Technically, yes, but it's not simplified because the square root of 1 is 1. Okay? On your homework, I'll accept it. On a test, I'll take points off. Okay? Unless it's multiple choice, then you just miss the whole thing. All right, add 2 to both sides. You cannot add 2 to I because those are not like terms, so your final answer was 2 plus or minus I. Okay, number 38 is where it started getting all crazy because you had fractions. Let me tell you, it's not the process that should be the problem. Well, fractions shouldn't be the problem either, but I found in last hour that the problem was the fractions. Okay, we should be good with fractions at this point. What are most of y'all? 9th grade, 10th grade? Annalise.
In your final answer, you always have to reduce, but when do you not?
It can't be reduced. What you mean?
But like you said, sometimes you just leave it.
Like during the problem, you said not to reduce when we're working it because it's easier to, like when you build a problem.
Right, in the middle of the problem, don't reduce. Okay?
When you final.
But when you get your final answer, reduce. Alright? Okay. Number 38 was this. Okay, when you have a number in front of x squared, you can tell if this is factorable by, since usually if there's no number, we'd say what are factors of 5 that subtract to give me 3, right? Okay. Well, now I'm going to take the product of these two and say what are factors of 10 that are subtract to give me 3? Are there any? Because 2 times 5, the products of those are going to be intermingled whenever you're doing your outer and inner. Are there factors of 10 that subtract to give you 3? 5 and 2. This is factorable. 2x times x is 2x squared. And 5 times 1 is 5. And if I put it here, that's 2x squared, that's plus 5x, minus 2x, which gives me 3x in the middle, and 5 times negative 1 is negative 5. That was factorable, okay? That's how you find the factors. That's how you tell if it's factorable, okay? If the product of these two, the product of them, if there are factors that you can use to get that middle term, then it's factorable. You need to go find them. All right, so here x was equal to negative 5 halves or positive 1. If you can factor it, factor it. Number 40, testing to see if it's factorable if we take the product of 3 and 1. Are there factors of 3 that add up to 5? No, it's not factorable. Okay, so we need to set this up for completing the square. Which means, first off, I can't have a 3 in front of the x squared, can I? So what do I need to do? I need to divide everything by 3, and in the process, I can move that last term over, which would make it become negative. So I have x squared